Hi everyone, this is Ravi Prakash and welcome to the 5th class of HCF LCM. Okay, so in this video, we'll combine HCF and LCM and we'll solve some good question, fantastic question from 5 onwards, right? First two we did HCF, second two we did LCM, right? Now we'll combine these two, fine? Okay, so before combining, let's write some key points here. First point, LCM is always some K into HCF. Okay. Second point, LCM is always greater than or equal to HCF. Right. Now, let's see these 2 points here. Take an example of 4 and 6, right? 4 and 6. What is the HCF of 4 and 6? The HCF of 4 and 6 is 2, obviously. Right, because I told you, na? 4 is what? 2 into 2 I can write. 6 is what? 2 into 3 in terms of co-prime. 2 and 3 are co-prime and 2 is the HCF, right? What is the LCM? LCM will obviously contain a 2 and then 2 and 3 are co-prime. So what is the LCM? 6. So 2 into 6 is 12, right? So you see, LCM is always a multiple of HCF, right? From where does this 2 comes? Here. Since their HCF is 2, so LCM also is a multiple of 2. And since LCM is always some HCF into always something, right? So always LCM will be what? Always greater than equal to HCF. It can never be less than equal to HCF, right? Then third point, for any two numbers, n1 into n2 is always equal to their HCF into LCM, right? So again, always true, right? n1 into n2 is always equal to their HCF into LCM. You see this is here only, right? Numbers are 4 and 6. So n1 into n2 is what? 4 into 6. Okay. So n1 into n2 is 4 into 6. What is the HCF? 2. What is the LCM? 12. See? 24 and 24 both are equal. Right. That means n1 into n2 is equal to HCF into LCM. Fine. For any two numbers. Okay. Then we can solve few questions based on this here. First question we can write. n1 into n2 is equal to 240 and their LCM we need to find if their HCF given is, let's say, 30. Okay. So what is the question here? n1 into n2 is 240. We need to find their LCM if HCF given is 30, right? So see, you can simply apply formula here, but this question has something extra, right? Because if you apply the formula, it will be wrong. n1 into n2 is equal to HCF into LCM. This is 240, this is 30, so you get LCM as equal to 8. But it is wrong. Why it is wrong? Because LCM will always be greater than equal to HCF. First key point of last slide, we proved it, right? So LCM is always greater than equal to HCF. LCM contains a multiple. Multiple means always greater than or equal to a number. HCF contains word factor, right? Factor means always equal to or less than the number. That's why LCM is always greater than equal to HCF, right? So this is what? This is wrong. What is the answer? Answer will be what? Answer will be data inconsistent. Answer is data inconsistent, right? So you have to be very careful, right, with the concepts. Then you can solve the problems. Okay. One more question. Now, n1, in this case, n1 into n2 is given as 144. Now, again, their HCF is 8. What is their LCM? Right. Again, you see this kind of question, you should be like, because if you solve this question, okay, so again, n1 into n2 is equal to HCF into LCM, right? So n1 into n2 is 144. HCF is 8. What is the LCM? So LCM is 144 by 8. What is 144 by 8? Right. So it is 18. Right. So LCM of two numbers is 18 and their HCF is 8. Not possible. This is not possible. Why? Because always LCM is always some K into HCF. That means LCM is always a multiple of HCF, right? Here LCM is 18 and HCF is 8. This is not possible. This is not possible. Okay. So again, what is the answer? Answer is again data inconsistent. Again the data is inconsistent, right? Okay, so very important this things, right? We good with the concepts, fine. Okay, now we can move to next question. Question is product of two numbers is 30240 and their HCF is 6. So how many such pairs of numbers are possible? How many such pairs of numbers are possible? Fine. So product of two numbers is 30240 and their HCF is 6. So how many such product pairs of numbers are possible, right? Fine. That's a good question, right? Because we'll use the funda in this. Always, now see, always while finding this thing, okay, this thing, we don't have to find the LCM here, right? We don't have to find the LCM. So I can simply write, so we can have the, we can use the concept used in HCF, right? Where product of two numbers is 6. So what I can write here, HCF is 6. So what are the numbers? 6A and 6B, where A and B has to be what? Co-prime. This question we did in HCF, right? Next question we'll do applying this LCM funda. Okay, just revise it. So 6A into 6B equal to what? 30240. Fine. So what is solved? We solved for A into B. We got A into B as 2 cube into 3 into 5 into 7, right? And since variables are not given, this is for unordered solution. So what is the unordered solution of this question? So unordered solution is what? HCF of two in how many ways a number can be written as product of two coprimes? So what is the unordered solution? It is 2 raised to n minus 1, where n is number of prime factors. How many prime factor it has? 2, 3, 5, 7, 4 prime factor, right? So 2 raised to 4 minus 1, 2 cube. Okay, this is 8. So 8 is the answer. 8 is the answer. Fine. Now, next question we'll do applying LCM funda in this. Okay, LCM funda in this. So next question. Okay, so the next question is HCF of, okay, next question is HCF of two numbers is 8. HCF of two numbers is equal to 8 and their LCM is equal to 62832, right? 62832. So how many such pairs of numbers are possible? Pairs of numbers are possible, right? So now in this case we can directly apply the funda. N1 into N2 is equal to their HCF into LCM, right? Now get back to the concept of HCF, right? Concept of HCF. We discussed last question also, right? If HCF of two numbers is 8, numbers can be written as 8A into 8B. That numbers can be 8A and 8B. So N1 into N2 will be what? 8A into 8B. Now what is their HCF? 8. What is their LCM? 62832, right? Their LCM is 62832. Once you cancel it, this 8 will get cancelled here. So A into B, you will get it as 62832 by 8, right? So A into B, you will get it as 62832 by 8. You will solve it like so. This 7854. So 7854. What is 7854? It is nothing but 7854 is equal to 2 into 3 into 7 into 11 into 17, right? So 2 into 3 into 7 into 11 into 17 is nothing but 7854. Fine. So if A to B is 7854, A into B is 7854, we have to find number of solutions, right? We have to find number of solutions, right? So again, same thing. In how many ways a number can be written as product of two coprimes? We have to find unordered here because variables are not given. So unordered solution is what? unordered solution is equal to what? 2 raised to n minus 1. So 2 raised to, there are 5 prime factors here, 1, 2, 3, 4, 5. 5 minus 1. So 2 raised to 4. What is the answer? 16. So 16 is the answer for this question. Fine. 16 is the answer for this question. Okay. So you can use this formula. HCF of two numbers is given as 8 and their LCM is 62832. So how many such pairs of numbers are possible? Okay. Okay. Now, let's discuss one important concept here, right? I'll add one more question here. See, and we'll discuss this question. Very important question now. How many pairs of integers of, or I should write positive integers of xy exists, of xy exists such that HCF of xy plus LCM of xy is equal to 119. Right. Now this is a super question, a bit lengthy, but the concept is worth knowing, right? So just pay attention to this question now and concept behind it, right? So how many pairs of integers of x comma y exist here such that HCF is equal to HCF of xy plus LCM of xy is equal to 119. Now see, I don't know the HCF, I don't know the LCM, right? So let's say HCF of x and y, I'm assuming to be h, right? HCF of x and y, I'm assuming to be h. Now, if HCF is h, the numbers can be written as n1 should be what? Some h into a, and n2 should be what? Some h into b. Where I know that a and b has to be what? They have to be co-prime. A and b has to be co-prime. Fine. So h into a and h into b are the numbers. Fine. Now, what is the LCM now? So if a and b are co-prime, what is the LCM? A into b. LCM of two co-prime numbers is what? Their multiplication, simply a into b, right? So what is their LCM? That means their LCM will be, or I can write here, their LCM will be, they both are multiple of h, so h will come, and a and b, their LCM will be what? A into b, so HAB, right? So their LCM is what? HAB. So HCF I assume to be h, and LCM is what? H into a into b. What are the numbers? Numbers are HA and HB. Numbers are HA and HB, right? Okay. So numbers are HA and HB. Fine. So how many pairs of positive integers xy exist such that HCF of xy plus LCM of xy is equal to 119? Now let's put this equation here, right? Let's put this equation. So equation becomes here HCF of xy is h. LCM of xy is equal to 119. So what is LCM of xy equal to what? So LCM of xy is equal to HAB. So h plus HAB is equal to 119, right? So h you take as common. So 1 plus AB is equal to 119, right? It's a very beautiful equation because what is 119? 119 is here expressed as a product of two numbers, right? One number is h, and what is the other number? 1 plus AB. So h into 1 plus AB is what? 119 now. Okay. H into 1 plus AB is what? 119. Okay. Now you have to find solution for this, right? H into 1 plus AB equal to 119. How many solutions? Okay. Now, let me rub this part. Okay. Because it will take some time to solve it now. You concentrate, and I'm rubbing this part. Okay. Rubbing this part. I'll just rewrite the equation as H into, okay, just rewrite the equation as what we discussed here. We discussed like, okay, so H plus HAB is equal to 119. It implies that H into 1 plus AB is equal to 119. So 119 here is written as a product of two numbers. Fine. Now, what is 119? 119 is nothing but 7 into 17. 7 into 17, right? So you can sense here, right? What we can do here? We can form many cases here, right? So like when this h can be 7, this can be 1 this can be 17, right? Or the reverse, this is 17, this is 7. Or 119 can be written as either 7 into 17 or 1 into 119, right? So basically you can sense that we will have 4 cases here. You can sense that we'll have 4 cases here. Okay, so what are those 4 cases? Those 4 cases are when first time H is 7 and 1 plus AB is 17, right? Then reverse, H is 17 and 1 plus AB is 7. Okay, 2 cases. Then third case, H is 1 and 1 plus AB is 119, right? And what is the third case after that? Fourth case, when H is 119 and 1 plus AB is 1. Okay, so let's discuss this 4 cases here. Now first case, case 1. H is 7 and 1 plus AB is 17. Now how many solutions for this question now? So if H is 7 and 1 plus AB is 17, that means AB is equal to 16. So if AB equal to 16, the simple funda is how many ways 16 can be written as a product of two coprimes. So now what is 16? 16 is just 2 raised to 4, right? So only one prime factor. So even if you go by formula, the unordered solution is what? 2 raised to n minus 1. So only one, n is only one prime factor, that is 2, right? So 2 raised to 1 minus 1, 0. So 2 raised to 0 is what? 1. Or you can directly think A into B is 16. How many solutions? Only one. 1 into 16. For this to be coprime. So only one solution. Right. So first case, only one solution. Okay. Unordered. Ordered will be 2 because variables are given. So ultimately I have to calculate ordered solution. Right. So unordered is 1. At last I'll multiply by 2. No issue. Right. And what is that one solution? That is 1, 16. You understand what is this one solution? It is 1, 16. Right. And 16, 1. Okay. So accordingly numbers will change. So HCF is 7. Let's discuss this case here. Even if I just need to find how many pairs, right? But just for conceptual understanding, discuss this case here. So when HCF is 7 and A is 1 and B is 16, so number becomes, what is the number? N1 is H into A. So 7 into 1, notice N2, 7 into 16. Okay, what are the numbers? 7 and 112. So 7 and 112 are one pair of numbers having HCF is equal to 7. And what is their LCM? Their LCM is 112, such that 7 plus 112, that is HCF plus LCM equal to what? 119. So this is satisfying, right? This is what we are searching for. So we have not intended to find this one, right? Simple, how many pairs? So here I can say only one pair, right? Only one pair. I hope you're getting it. Very good concept, right? Please understand. Okay. Now, case 2 we'll discuss. Case 2. For case 1, 1 is the unordered solution. Now we'll multiply by 2 because we have to find ordered. So ultimately it will be 2 only, right? So 2 solutions, 2 ordered solution for first case or 1 unordered for first case, right? Now case 2. When H is equal to 17 and 1 plus AB equal to 7. In that case, AB equal to 6. How many solutions? AB equal to 6. Only 2 solutions, right? 2 unordered because 1 into 6 and 2 into 3. Okay, so 2 unordered or ordered 4. So 2 unordered, right? Or total I can write 4 solutions. Ordered 4 solutions, right? So it is also for ordered. Let me round for ordered. Okay. So I'm putting a round for ordered. Here 2 ordered, here 4 ordered. Okay. Now case 3. Now when H is equal to 1, so 1 plus AB is equal to 119. In this case, AB is equal to 118. What is 118 now? Simply 59 into 2, right? So again, how many solutions? Since only 2 prime factors, so how many solutions? Only 2 solutions, right? That is 1 into 118 and 2 into 59. That's it, right? So either only 2 unordered or 4 ordered, right? So again, 2 unordered or 4 ordered. So you can write 2 unordered and 4 ordered, right? That is 4 is ordered. Since variables are given here, so 4 ordered I have to take, right? 4 ordered. Now, case 4. Now you can sense that case 4 won't exist, right? Why case 4 won't exist here? Case 4 won't exist because in case 4, 1 plus AB, right? H has to be equal to what? H has to be equal to 119, na? Okay. So H has to be equal to 119 and 1 plus AB is equal to 0. Sorry, 1 plus AB equal to 1. That means A into B equal to 0. That means one of the numbers is 0. That is not possible, right? If one of the numbers is 0, their HCF will also be 0. Their LCM will always be 0, right? 0 plus 0 will not be equal to 119. So in that case, this is not possible. So case 4 is not possible, right? So total how many solutions? 4 here. 4 plus 4, 8. 8 plus 2, 10, right? So sir, total 10. So answer is total 10 solutions is the answer for this question, right? It's a very good question, right? It's a very good question. Okay, so what was given? HCF of XY plus LCM of XY equal to 119. Okay, so let assume what we did, we assumed HCF to be H. So if HCF is H, the numbers are what? HA and HB, where A and B are co-prime. So if two numbers are HA and HB written here, two numbers are HA and HB. Okay, what is their LCM? So LCM is what? Both are multiple of H, so H will be here at the LCM, and A and B are co-primes. What is their co-prime? What is the LCM of two co-prime? Their multiplication only, because they both have nothing in common. LCM of 5 and 7 is 5 into 7, right? Because both are co-prime. So LCM of A and B is what? Is A into B here. Okay. So HCF is H. So I've written the equation here. HCF is H. LCM is HAB. So H plus HAB equal to 119. That means H into 1 plus AB equal to 119, right? Now there will be 4 cases, because this equation says that 119 is written as the product of two factors. So one is this factor 1 plus AB, another is H, right? So 119 can be written as a product of two factors in two ways. That is 7 and 17 and 1 and 119, right? So you can sense that they will have 4 cases here. Why 4 cases? Because if one time H is 7, then 1 plus AB is 17, and the reverse second case, when 1 plus AB is 7, so H is 17. Similarly, 2 cases here also. H is 1 and 1 plus AB is 119, and reverse H is 119 and 1 plus AB is 1, right? That reverse case, that is case 4, is not possible. Case 4 is not possible. Why? Because if H is 119, so 1 plus AB equal to 1. That means AB is 0. So AB 0 cannot be possible, right? Because one number A into B is 0. That means one of the number is 0. So if one of the number is 0, then HCF, LCM all will be 0, 0, right? 0, 0, right? So I can't get 0 plus 0 as 119 here. So fourth case gone, right? So the third case was, so first case was H is 7, 1 plus AB is 17. So AB is equal to 16. So if AB is 16, how many ways of writing 16 as product of two co-primes? Only one way. 1 into 16. That's it, right? So unordered, only one way. Ordered, two way, right? You can also apply formula. What is the formula? 2 raised to n minus 1. But n is only 1 because only one prime base is here. Only one prime base. So 2 raised to 1 minus 1. 2 raised to 0 is only 1. So one solution for unordered or 2 for ordered. Similarly, H is 17. 1 plus AB is 7. So here AB equal to 6. So table 2 unordered. 6 is what? 1 into 6 and 2 into 3 as a product of two co-primes. So 2 unordered means what? 4 ordered. This is for ordered, right? 4 ordered. Similarly, third case, H is equal to 1. 1 plus AB is 119. So H equal to 1. 1 plus AB is 119. That means AB is what? 118. So if AB is 118, it is 59 into 2. 59 and 2 both are prime numbers, right? So only 2 ways for writing is 1 into 118 and 2 into 59, right? There are 2 unordered or 4 ordered, right? So I want ordered solution because in question variables are mentioned. So variables are mentioned, that means ordered solution, right? So 4 plus 4 plus 2, total 10 solutions, right? A super question, a super important question also for exam, right? So please practice it. I'll give another question quiz similarly like this, right? Similar to like this. So please practice. Okay, thank you.